Rankine's at pressure theory. So now the thing is, it's very interesting theory, very important theory, very important theory. So now you see, I will write assumptions. Many times you see, whenever we start any theory, we use it to write assumptions. So now it is time to discuss assumptions. Assumptions. Let me tell you the first assumption. Backfill is dry and cohesionless. ఇదేంటి సార్ ఇవన్నీ మాకు మీరు చెప్పేశారని మీరే చెప్తారు. Backfill is dry and cohesionless. So your understanding C0. There is no water table. There is no water table. That means pore water pressure is 0. So initially we are having these assumptions, but we will break all the assumptions and limit what I say limitations. So now next, backfill. Now backfill is homogeneous and isotropic. Now the next, you can guess, backfill is semi-infinity. This is a very interesting point. Next point, failure surface is planar. And this is very important. Back of the wall is smooth and vertical. This is very, very important. Back of the wall is, this is the main difference between Rankine theory and Coulomb theory. Back of the wall is smooth and vertical. Please all of you underline this point. Back of the wall is smooth and vertical. So that's why, so now if you want to see the picture, every time we are drawing now, so this is Rankine's theory, you can see now. This is the retaining wall. It may be constructed with RCC or CC, cement concrete or masonry. So now this is backfill, and I should write this one more assumption, because backfill surface is horizontal. But you don't forget this. You please remember, if you forget my name also, I don't worry. But you don't forget this point. Back of the wall is smooth and vertical. Now let us write now. So you see here, this is a retaining wall. So you know the backfill level, ground level, it is absolutely horizontal. So this is the assumption or limitation, what I say. So you can see this is the height of the wall, H is height of the wall. Now you see, whatever I am showing is very important. Back of the wall is smooth. You write me like what is the way I am writing, smooth and vertical. If you want to show it is vertical, you draw perfect straight line. Okay. So this is 90 degrees. So back of the wall is smooth and vertical. Now it is very important to show you. This is the failure surface. This is the failure surface. This is the failure surface. So now it is planar. Failure surface is planar. So this is about figure Rankine's at the pressure theory. In fact, actually, Rankine's theory and Coulomb's theory, what we are discussing now, you can see here, Rankine's theory and Coulomb's theory, both are classical earth pressure theories. They are classical, you know, they are classics. No one can replace those theories. Classical earth pressure theories. Among both, many times we engineers love Rankine's theory. That's why I started discussing with you people about Rankine's theory. So backfill, backfill means it is my duty to show you this is backfill. The soil is backfill. So here you see, back of the wall is smooth and vertical. Smooth means, let me tell you, smooth means there is no friction between. There is no smooth means, I will tell you the meaning of word smooth. I will pick another color. Smooth means the friction between wall and soil is neglected. So that is the meaning of smooth. There is a friction between backfill and this retaining wall. So that I am trying to ignore. Whereas in Kulup's theory, we are going to consider that. It is good to consider the wall friction. If you consider wall friction, the friction between this backfill and wall, back of the wall, if you consider lateral earth pressure will be reduces.